the unit circle, and that implies that the radius is 1. I'm going to draw a circle using a compass, and this is going to be a unit circle. That's a radius equals 1, and that's a circle. Okay, now I've divided this circle into 4 quadrants. The first quadrant, this is the x-axis, this is the y-axis, I'm going to divide the circle into different sectors using the protractor. Right, so I'll get the point of the center here as the center, and I need to mark 30 degrees, 45, just marking 60 there, 90, and 120, 135, 150, and that's it. So I'm going to join the lines. You need 2 points to join a straight line because of the direction of the line. So you need to know which direction the line is going. So I've done the points here. So let's just mark those points we've done. This is 30. And the point here was raised. So it's basically what you've done is we kept this fixed and we just moved that point and raised it and create a gradient. So this is 0 gradient, no gradient, a positive gradient. So that generated an angle which is called theta, and that would then create a x coordinate and y coordinate there. So let's label this angle. So this angle is 30 degrees. This is 45 degrees. That is 60 degrees. 90, 120, 135, 150, 180 degrees, 210 degrees, 225 degrees, 240 degrees, 270 degrees, 300 degrees, 315 degrees, 330 degrees, 0, and 360 degrees. So we start with 0 to 30 to 45, 60. Now the circumference, which is 2 pi r, where r is 1, so the radius here r equals 1, and that is 2 pi radians, and that equals 360 degrees. What that meant is pi is equal to 180 degrees. If that's the case, 90 is going to be pi over 2. If 180 is pi, 60 is going to be pi over 3. Just divide 180 by 3, you get 60. Divide 180 by 4, you get 45. So 45 is pi over 4. Divide 180 by 6, you get 30. So 30 is pi over 6. Well, if 60 is pi over 3, times 60 by 2, you get 120. So that would be 2 pi over 3. If 45 is pi over 4, times it by 3, you get 3 pi over 4. If 150, if 30 is pi over 6, times it by 5, you get 5 pi over 6. Now, 210, if 30 is pi over 6, times it by 7, you get 7 pi over 6. 225, well, times 45 by 7, times 45 by 5, sorry, you get 225. So you get 5 pi over 4. 240 times pi over 3 times 60 by 5 by 4, you get 240. 4 pi over 3. 270. If you times 90 by 3, you get 270. So that will be 3 pi over 2. 300. 30 by 10, you get 300. Or if you times 60 by 5, you get 300. So that would be 5 pi over 3. Now, 315. If you times 45 by 7, you get 315. So 7 pi over 4. If you times 30 by 11, you get 330. So 11 pi over 6. And this is 2 pi for 360. Okay, so now if I get the coordinates down, the coordinate here, if I trace that line to the x-axis, you can see this height here is y, because that's y, and the distance from the 0 here to there is x. So that's x, and this is y. And that has an angle, theta. Right, so what I've done is I've reproduced this triangle here. The longest side of a right angle triangle, so this is right angle, is called the hypotenuse. This is the adjacent to this angle, and this is opposite to that angle. To this angle, this will be the opposite, and to this angle, this will be the adjacent. We're going to use SOHCAHTOA. S stands for sine, O for opposite, H for hypotenuse. C stands for cosine, which means complementary of sine. And T stands for tangent. Tangent is basically the slope here. Zero tangent, zero gradient, positive value for tangent. There's a positive slope here. You can go up the hill. Positive increasing, increasing, infinity tangent, difficult to climb. Okay, so tangent describe the gradient. So we want to see what sine describe and cosine describe. So the definition for sine of an angle theta is sine of that angle is, which is that one here. So sine is opposite over hypotenuse. The opposite is y, and the hypotenuse is 1, because the radius of the circle is 1. So that's the radius, 1. And cos theta, which is called cosine, written as cos theta, is adjacent over hypotenuse. Adjacent is x, hypotenuse, adjacent over hypotenuse. Hypotenuse is 1, so that'll be just x. So the cosine describes the x value and the sine describe the y values. So the x value is cos of an angle theta, and the y value is sine of an angle theta. So the y describe the vertical value position, and the x and the cosine describe the horizontal position. So now we've got that, we now need to find the values for the coordinates for 30, 45, and 60. To do that, I have managed to draw these two shapes. This is equilateral triangle. That means all sides are equal and the angles are equal. So what I need to do is, if I bisect this angle, just make it, because it's symmetrical, so this angle here will be 30, and this is 60 because it's equilateral triangle. The side here is 2, so that's 2. This must be 1, that must be 1. And therefore, I need to find the height here. To find it, I need to use Pythagoras theorem. The Pythagoras theorem says that, well, 2 squared equals 1 squared plus the height h squared that I'm looking for. And that implies that 2 squared minus 1 squared equals h squared. So to find my h is going to be 3, because 4 minus 1 is 3, and square root it. So this is root of 3. So that is the height here, root 3. Now I can use that to find the angle for 30 degrees. Sine of 30 degrees, this is now the opposite for 30 degrees. This will be the opposite for 60 degrees. So sine of 30 degrees is opposite over hypotenuse, a half. But I need cos 30 as well. Cos 30 is adjacent over hypotenuse. So the coordinate for this one is going to be root 3 over 2 and a half. So that's the coordinate for that. To find 45, we just draw the diagonal here. Let's name these. We're using a square, by the way. 1, 1. And this will come root 2, because it's 1 squared plus 1 squared. I can write it here. So that'll be 1 squared plus 1 squared equals to the diagonal, and that implies d squared, and d squared equals 2, which implies that d equals root of 2. So that's how I get the root of 2. Again, I'm using Pythagoras theorem. So if in doubt, using Pythagoras theorem. So just write it here. So that's what I'm using there, Pythagoras. And this one is also Pythagoras. Now I know this is 45, by the way, because this is 90, so that's 45 degrees. Cos of 45 is adjacent over hypotenuse. When you write 1 over root 2, we have to rationalize the denominator, because root 2, 1 over root 2 is not allowed. So we multiply both numerator and denominator by the surd, which is root 2 in this case. Root 2 times 1 is basically root of 2 over root 2 times root 2. Using indices, that's just 2. So that's how you write 1 over root 2 is root 2 over 2. So you'll see it in some books. They'll be writing 1 over root 2, but they should really be writing root 2 over 2. Cos 45 is 1 over root 2, which is root 2 over 2. So you write here root 2 over 2. And then sine 45 is 1 over root 2. So that's root 2 over 2. Now remember, this is what we're using: sine, cos, tan. Opposite over hypotenuse, this is the opposite of that, and this is the adjacent. 60. Well, for 60, apply SOHCAHTOA. Sine cos 60 is 1 over 2, so that's just 1 over 2. And sine 60 is opposite over hypotenuse, root 3 over 2. Now to find the coordinate of these ones here, it's a lot easier now, because we're just using the same coordinate here. We're just using this, but the sign would change. So you got minus x plus y, plus x plus y, minus x minus y, plus x minus y. It depends which quadrant these are. So in this quadrant, second quadrant, x is negative, you can see that. But you see, if you extend 120 to 60, they will have same coordinate, same value of y. You see, same value of y. And this value of y here is root 3 over 2. And the x will be the same, but the vector will be different. Vector means direction, so it's negative here. So to write this for y, it's going to be minus a half for the x value, and y will be the same, root 3 over 2. Now that means cos 120 is minus a half, sine 120 is root 3 over 2. For 135, if you extend the line, it goes all the way to 45. So you see, the y values are the same. These are the y value, they're the same. And the x value is just a reflection of the other ones. So one is positive, the other is negative. So you're going to get minus root 2 over 2 and root 2 over 2. 150, again, if you extend it, you get 30, same height as 30. So y value is same. But the x value is just negative, and the other is positive. So we get root 3 over 2 minus and a half. So what's going on here? What we're using, if you notice what we're actually using something called root over 2. So that's what we're using. You can see here is root 1 over 2, just put 1 there. Here is root 2 over 2, just put 2 there. Here is root 3 over 2, just put 3 there. So 1, 2, 3 for each one of those. And on this side, again, root 1 over 2, just put 1 there. Root of 1 is 1. Root 2 over 2, just put 2 there. Root 3 over 2, just put 2 there. If you can remember it that way, it's good. But don't want you memorizing it, just derived it. Don't memorize it. If you can link it, that's good. Okay, next one. So the same thing appears here, except once you know this one, then the rest is easy. Just change the values of the x direction. But make sure they're aligned because they have the same height for y. And the x's are just reflected along the y-axis. Okay, so that's it. Now to find 90, we haven't done 90. Well, x is 0 here, right? So x is 0 here, but y is maximum here, so 1. So you're going to get 0, 1. For here, x is minus 1 and y is 0. So minus 1, 0. So what that meant is cos of 180 is minus 1, sine of 180 is 0. Cos of 150 is minus root 3 over 2. Sine of 150 is a half. So that's what this meant. Right. 210. Well, if you just take your ruler, you can see that's extended again. Same height of x, same x values. X is the same, yes. X is the same because it's that point here, X value. And their Y's are the same, but the directions are different, negative and positive. So all here is negative. So it's going to be same value, basically, but the Y values here will be not positive, but negative. So I have minus root 3 over 2 minus a half. And for 225, again, if you just, it goes well with 225 and 135. They're really, and also 45 as well, because they all linked together, see? So right angle triangle there. Right angle triangle. Okay. Now, again, you're changing the, so it's going to be minus root 2 over 2 minus root 2 over 2, or root 1, root 2. You can suspect the next one will be root 3, right? Root 3. So this one is decreasing, so it's going to be minus a half and minus root 3 over 2. Okay. And if you can see from here, it's, if you extend that 240, you can see minus, that's a half, root 3 over 2, or if you extend it to that, same X values, but the Y is reflected, one is positive, one is negative. There you go. Now 270, basically you are reflecting that along the X-axis, so that will be 0 and minus 1 for Y. So that means cos of 270 is 0, sine of 270 is minus 1. We can try and check it on the calculator. So switch it on and just put cos of 270, 0, and sine of 270, supposed to close the bracket, and minus 1. So it's correct. Now, all here will be Y will be negative, but X will be same because X is same for that, see? So this is going to be a half because it's same for that. 60 and 300 are aligned. And but the Y is going to be negative, so minus root 3 over 2. 315 and 45 aligned, so root 2 over 2 minus root 2 over 2. Then 330 aligned, so you're going to get root 3 over 2 and minus a half. X is 1, because you see that? The positive side, and Y. X is minus 1, the X is 1 here, and Y is 0. So let's try, see, just put that in there and see cos 360 should be 1. So press cos 360, close bracket, that's 1. Sine 360, close bracket, that's 0. Okay, so that's plus 1 and 0. Right, so that's the relationship you get there in generating the coordinates, and also it helps you to be able to simplify. If you're to write cos 135, you can see that that's minus root 2 over 2. They expect you to kind of understand how you get there. Sine 120 is root 3 over 2, which is same as sine 60. So they expect you to know how to get there. Another thing we need to realize is this is using Pythagoras here. I can say that x squared plus y squared equals r squared. And that implies that x squared plus y squared equals 1. Because r is 1, 1 squared is 1. So if I replace x with cos theta, so I get cos theta squared plus sine theta squared equals 1. But we don't write it as cos theta squared. It's exactly the same thing. We just write it as cos squared theta plus sine squared theta equals 1. So if you see cos squared theta, it actually meant cos theta squared. If you see sine squared theta, it means sine theta squared. If you see sine cube theta, it means sine theta cube. So that's how we write those. And that equals, so this is the fundamental trig identity equation. That's fundamental trig identity. The other important equation here is if I write my tan theta, because I've written sine theta is equals to y, cos theta equals to x. So to write tan theta, we can write it here. So tan of theta equals, tan is opposite over adjacent, so that's y is opposite and adjacent is x, so y over x. And that can become, well, we can write tan theta as, and y is sine theta over x is cos theta. So tan theta, which is the gradient, right, or the slope, is sine theta over cos theta. That means that height over that width will give you the gradient of this slope. And that's how you find it. So tan theta describes the slope of the wave, of the curve. Cos theta is describing the position along the x-axis. Sine theta is describing the position along the y-axis. And don't forget, you could use that to fill in those values, but it's always important to know where all this is generated from. That's from a square. I use a square because I can get 45 degrees from a square. If I divide it by 2, this is 90 here. And I use an equilateral triangle here and to generate 30 and 60, and then use Pythagoras to find the height, and then find the sine 30, sine 60, cos 30, cos 60. And then we can find the zeros because it just lie horizontally and vertically.